The kamikaze drone from Iran, called the Shahed-136, has become a major topic in modern warfare. But why is this drone such a big deal? This Russian caliber cruise missile costs around $1 million. The American Tomahawk cruise missile costs close to $2 million. But when compared to the Shahed-136, it is more like a low-budget cruise missile, with a reported cost of just $10,000 to $20,000, depending on the variant. When launched in swarms, these drones become a serious threat on the modern battlefield. In this video, we will look at how this drone works, its engine, and the step-by-step process behind its operation. We will also look at its limitations and how it can be countered. This is Shahed-136. Now let us start with what this actually is. The Shahed-136 is a loitering munition, also known as a kamikaze drone. A loitering munition is designed to stay in the air, circle over a target area, and wait for the right moment to strike. Unlike traditional missiles, which go directly to a fixed target, this drone can search and then attack when a target is identified. It has its advantages and disadvantages, which we will clarify later in this video. Now let us look at the specifications. The drone has a reported length of around 3.5 meters, with a wingspan of approximately 2.5 meters. It uses a delta wing configuration. When compared to a human, we can better understand its overall size. The drone weighs around 200 to 220 kilograms. Out of this, a portion is the warhead, which detonates on impact. Now let us look at one of the most interesting parts of this drone, the engine. All of this is powered by a small piston engine. It is a two-stroke scooter engine, which produces around 50 horsepower. It is cheap, simple, and easy to produce. Let us look at how it sounds like. Now let us look at how this drone is controlled. These are the control surfaces, also known as flaps, which help adjust the drone's direction and keep it stable during flight. Now let us look at the range of this drone. Depending on the configuration, it can travel up to 1,000 kilometers, and in some cases, up to 2,500 kilometers. Now let us look at how this drone finds its target. Some variants are equipped with anti-radiation seekers, which detect enemy radar signals and guide the drone toward the source. Inside the drone, this system processes the signal, allowing it to track and lock onto the target. Once locked, the drone continues directly toward the emission source. Now let us look at what is inside the belly of this drone. This is the RATO, or rocket-assisted takeoff, which we will be explaining later in the video. Now let us look at the basic step-by-step process of how this works. Step 1. The drone is transported using a simple truck carrier, which appears like a standard cargo transport vehicle. Inside, multiple drones are stored and ready for launch. Step 2. Navigation data, such as GPS or similar systems, is fed into the drone before launch. Step 3. The drone is prepared for launch. The launcher is elevated, positioning the drone for takeoff. Once activated, the drone is launched using a rocket-assisted takeoff. This provides the initial thrust. Once in the air, the RATO is ejected, reducing weight and allowing the main engine to take over. Step 4. These drones are launched in groups, typically 5 to 10 at once, to overwhelm enemy air defense systems. Step 5. The drone flies at extremely low altitude, which makes it difficult to detect on radar. In addition, the drone is relatively small and uses a composite structure, which further reduces its radar visibility. Because of this, detecting and tracking the drone becomes more challenging for air defense systems. Step 6. Once the drone reaches its target area, it begins its final approach. The drone then dives toward the target at full speed, and upon impact, the warhead detonates, destroying the target. To counter these drones, systems like the Flak Panzer Gepard are used. This is a German self-propelled anti-aircraft system, equipped with radar and twin rapid-fire guns. It is designed to detect, track, and destroy low-flying targets. It is highly effective against slow and low-altitude drones. Another system is the Soviet Zu-23, a much simpler and cost-effective anti-aircraft gun. It is designed to engage low-flying aerial targets at relatively short range. Despite its simplicity, it has proven to be effective against these drones. Both systems provide a more practical solution compared to using expensive missiles. Despite these counter systems, when multiple drones are launched, some will still get through. This makes them a serious threat on the modern battlefield, especially when used in large numbers. They can overwhelm defenses and strike their targets. The Shahed-136 shows one important shift, where cost and quantity can be just as powerful as advanced technology. But the real question is, can modern air defense systems keep up with swarm attacks like this? Let me know your thoughts in the comments. And if you found this video helpful, consider subscribing for more content like this.